So welcome. We have during this project been designing our own Snake game. The goal of the project was to design the game in a way so that all of the game logic was designed as a C program, then compiled into the LC3 assembly language, and then transferred to the LC3 system running on our FPGA board. So the game logic runs on this board, and then we use this PC as a virtual graphics card for rendering the graphics and stuff like that. So it's completely separated. All game logic is there, and all rendering goes on over at the PC.
The way the graphics is rendered is by first transferring some characters from the serial port on this device to the computer here, and then we take...
So basically the serial port is the communication channel between the LC3
board
system on the board and the PC.
Yeah. And what we do then is to compare the characters' ASCII code, and based on that we draw a specific sprite, which you can see here. And actually we support 2 layers, which means when the game starts, it's actually possible to have the snake move behind the skull in the upper right corner there, which will be visible now.
Yeah.
So basically we have 2 layers in order to combine 2 sprites. And as you can see, the snake actually moves 1 sprite each time. And the screen is then split into a grid with 40 columns on the horizontal and 32 on the vertical.
Yeah.
And basically that's why it looks more like a widescreen game than a normal.
Yeah, and we have implemented a serial communication protocol which takes care of only transferring data for the fields that needs to be updated. So right now the only information being transferred is information about the snake's head and the tail. So the rest doesn't need to be updated, so it doesn't have to transfer that.
Okay, so can you talk a bit more about what happens? I mean, this board that you're using with the LC3 system, is it something that you've built yourself? I mean, the LC3 system is something that you build yourself?
No, that was provided to us by the lecturer.
Okay, and so you've just done the program, the embedded programming on that board?
Yeah, that's...
So it's basically a form of hardware acceleration rather than hardware design. So you, the lecturer, provided the VHDL binaries, which is then interpreted and actually generates an entire PC system, or not a PC system, but a computer system, which is then able to run our code, which is basically LC3 instructions.
And on the PC, what exactly have you done? So you say you build the graphical part. So is it like a virtual graphics card you built, or?
Yeah, basically.
Basically, yes. What we did was to create a communication, use a communication library to communicate over the serial port, and we wrote this virtual screen in Java, which then takes the package it receives from the board and renders it on the screen.
Yeah, and it uses a specific refresh rate for when it needs to be updated.
And we can control that rate on this board too. So actually the screen here just reacts to what it receives. We don't try to manipulate the packets in this end.
The PC program, how did you write it? What language did you use?
Java.
Okay, and for the graphical part?
We used the Swing library in Java. The only logic that resides in the PC is actually the one we use for storing the high scores. Everything else goes on the FPGA board.
Okay, thank you.